Hi everyone. In the Matter and Solutions unit, one of our broad goals is to take all of this matter that's all around us and to basically divide it into really big categories. So today we're going to talk about one of those categories, and it is called pure substances. And we're actually going to break that down further, as you'll see in a second, into two other categories. But just so you know, later on in the game we'll talk about this other broad set of things called mixtures, but we're going to save that for a later video. So today let's talk about pure substances. Now, like I said, pure substances actually have two different definitions within that category. One of those is elements, one of those is compounds. So elements and compounds are different, but the thing that makes both of these the same is that they both have a chemical formula. So let's take a look at both of those different types, and then we'll get some practice kind of distinguishing between the two. If we look at elements, elements are those things we find on the periodic table, and they have a really basic building block. We call that an atom, right? So an atom we kind of think of as the simplest form of any substance or any type of matter or really any element. And there are many different types of elements. You see them all over the periodic table. And so they also have a formula that goes along with them, or letters. So you see here on the left-hand side we have silver. Silver has letters Ag on the periodic table, and bromine has letters Br. And one of the things that we'll talk about is that Br actually always exists in pairs of two. Make that a 2. And so we call bromine a diatomic element, and you can see over here in the picture that all of these have two little bromines stuck together, but we actually still distinguish both of these as elements. So because even though there are two bromines, because there's only one type of atom here, it's always just bromine, we're still going to call that an element. Silver obviously only has one silver, so because there's only one formula there, one set of letters, you'll notice that we are going to call that an element as well. Let's talk about compounds. So compounds are things that could be chemically broken down further. So for instance, you'll see here in the picture that we have water, and I know it's really small, but water is H2O. And what's going on in the picture is that we're splitting that water, we're splitting it into its constituent parts. So we're splitting it into oxygen, and we're splitting it into hydrogen. And so hydrogen and oxygen, H2 and O2, we would call those atoms because we can't break those down any further. Maybe we could split one H from another H, but you'll notice that those are both H's. So we still call this an atom. Same thing with the oxygen because they're the same type of element. But H2O, this is made up of different types of elements. We got H's going on, we got O's going on. And so that's why we call it a compound, because we could break it down further into those constituent pieces. If you want to pause the video at this point, that might be a good plan so that you can get some practice writing in these practice problems, and then we'll come through and we'll discuss the solutions to those practice problems in a second. So hopefully you've had a chance to pause the video and try the practice problems. Let's first talk about what is an element. So an element, very simply, is something that's found on the periodic table and something that you can't really make any simpler than it already is. It's only one type of symbol, chemical formula. There's only one letter there. Even in something like He, which is helium, I recognize that there are two letters there, but you'll notice we have a capital and then the lowercase. So this is only one type of chemical, one type of compound. This is helium. An element is something we cannot break down any further. Let's talk about the difference between a chemical element and a chemical compound. So like we just talked about, these compounds, those are things that can be broken down further, whereas elements cannot. So if we had something like NaCl, NaCl is sodium chloride or table salt, we can split NaCl into Na and Cl. Cl actually happens to be Cl2. We'll discuss that later on. But again, we're able to split this Na and Cl into two different things, so that's a compound, whereas the Na and the Cl by themselves, we would call those elements. Why are they considered to be pure substances? Well, these are both considered to be pure substances because they have a unique set of physical and chemical properties and they have chemical formulas. So yes, chemical substances have a unique set of physical and chemical properties, but the way that you can tell, because you can't always see physical or chemical properties, is that they're going to have a specific chemical formula. And that's what differentiates the things we're talking about today from things like mixtures. So if you think about the milk in your fridge, right? Here's some milk. If I asked you what is the chemical formula of milk, there isn't really one, right? It's not H2O, that's water. It's not NaCl, that's table salt. It's some combination of all of those. So milk is actually a mixture. And we'll talk about mixtures later on, but it is not a pure substance because it does not have a specific chemical formula. Let's talk about why silver and bromine are both considered atoms or elements, even though bromine contains 2 atoms. Well, like we said before, silver has the formula Ag. It's all Ag all the time. Bromine has the chemical formula Br2, but because there aren't 2 different types of atoms going on there, we still call this an element because it's all made out of bromine. Let's identify whether these are elements or compounds, and I bet you it would help to go ahead and write out our chemical formulas. So for water, we know that's a compound. Why? Because it has the formula H2O, 2 different types of atoms. For O2, O2 already has a formula written out for us. That's an element because all we're dealing with is oxygen. For iron, iron also has a chemical formula. It's Fe, and you'll notice if it's just Fe, that is an element because we're not changing from one thing to another. We can't split that Fe down any further. Finally, KMNO4, we could definitely split KMNO4. There are 3 atoms going on there, and so, or 3 types of atoms, I should say. And so we could split that into potassium, manganese, and oxygen. So this